Is it okay? Good morning, sir. Good morning.
Yeah, good morning. Good morning.
Sir, check చేద్దాం మాస్టర్ presentation.
అదే చెక్ చేద్దాం. ఇప్పుడు వచ్చింది, ఇంతకు ముందు రాలేదు. ప్రెజెంటేషన్ అప్లోడ్ చేయడానికి తీసుకుందా ఇప్పుడు?
ప్రెజెంట్ మామూలుగా మీరు కర్సన్ కొంచెం పైకి జరిపితే మాస్టర్ ప్రెజెంట్ నౌ అని వస్తుంది.
ఓకే,
ప్రెజెంట్ నౌ. దాని మీద క్లిక్ చేస్తే విండో అని వస్తుంది మాస్టర్. యువర్ ఎంటైర్ స్క్రీన్ అండ్ ఏ విండో. ఓకే, ఇప్పుడు మీరు ప్రెజెంటేషన్ మీదకి వెళ్ళి క్లిక్ చేయండి మాస్టర్. ప్రెజెంటేషన్ మీదకి వెళ్ళి క్లిక్ చేయండి. ఆనంద్ గారు, చైతన్య ఆర్ ఆనంద్? ఆనంద్ గారు, గుడ్ మార్నింగ్ అండి. మరి ఆయన మ్యాష్ గారికి ఒకసారి Sir. Hello. Sir, your mic is off. Sir, మీ మైక్ మ్యూట్ లో ఉంది మాస్టర్. మీ మైక్ మ్యూట్ లో. Sir, చెప్పండి.
Okay. But now, whenever I am making a presentation now, PowerPoint is getting stuck.
నాకు పంపించండి మాస్టర్ పవర్ పాయింట్ ప్రెజెంటేషన్. నేను ఇక్కడ నుంచి ప్రెజెంట్ చేస్తూ ఉంటాను, మీరు జస్ట్ అక్కడ చూసి చెప్తారు.
ఓకే.
నాకు ఈమెయిల్ ప్రెజెంటేషన్ పంపించండి మాస్టర్. వచ్చింది సార్. ఇప్పుడు కనిపిస్తుందా సార్? సార్ 5 more minutes. కొంచెం అంటే యూట్యూబ్ లైవ్ స్ట్రీమ్ వాళ్ళు సెట్ చేసుకుంటున్నారు. జస్ట్ 5 more minutes. Good morning. Alumni, my dear participants, a very good morning to all of you. It is indeed a great pleasure and honor for me to welcome Dr. Sanjeev Rao Garu, Advisor, Research and Development, Yale University. He was a senior scientist in Department of Science and Technology, New Delhi, and also worked as an advisor and coordinator for Science and Engineering Research Board, New Delhi. So, coming to his initial days, Dr. Sanjeev Rao Garu obtained his MSc and PhD in agrometeorology from Andhra University. So, we are very proud of you, sir. During early 1986, Dr. Rao Garu joined as a junior scientist in Agromet. He is the first agrometeorologist to initiate scientific studies on agrometeorology of rubber plantation at the Rubber Research Institute of India, Kottayam. At the same time, in his during early 1992s, and he joined as a senior scientist, officer 1 grade in the National Center for Medium Range Weather Forecasting, Department of Science and Technology, and he was very closely associated with the development and extension of the agrometeorological advisory services to the farmers. Later, Dr. Rao Garu was responsible in administrating in the Indian Weather and Climate Research in DST in various capacities as Principal Scientific Officer, Director, Scientist F, Scientist G, and Advisor and a Research Coordinator for SERB. Apart from his scientific management, he developed expertise in agroclimatic characterization, crop weather interaction, modeling leaf wetness duration, disease outbreak forecast, irrigation water management, location specific agromet advisory, and monsoon variability. So he had 25 years of experience as a member of program advisory committees and monsoon and tropical climate, agrometeorology, Indian climate research program, atmospheric sciences, and Himalayan glaciers. He was very instrumental in developing and publishing the vision for research and development in agrometeorology in the science plan, and he implemented plans for Indian climate research program, mesoscale modeling, dynamics of the glaciers in the Himalayas, and also he is responsible for planning and implementation of the several large-scale multidisciplinary and multi-institutional collaborative field observational studies like LASPEX, Land Surface Process Experiment, BOBMEX, Bay of Bengal Monsoon Experiment, Arabian Sea Monsoon Experiment, Storm Projects, and ERMP, Extended Range Monsoon Prediction, and Continental Tropical Convergence Zone, CTCZ. Also is responsible for establishing stratosphere troposphere radar facility at Nainital, Cochin, and Kolkata. He was very instrumental in creating basic research infrastructure at different knowledge institutions in India, organizing SERC schools and WRF modeling training program. He received fellowship from World Meteorological Organization for his postdoctoral research at the University of Guelph, Canada, and he was also an elected member of Fellow of Academy of Sciences and Fellow of Indian Geophysical Union, Fellow of Science Society of Earth Sciences, Life Member of Indian Meteorological Science. There are so many things are there. Dr. Sanjeev Rao Garu has been nominated as a member for several scientific delegation and technical expert committees of the government of India towards fostering knowledge collaboration in India and abroad. Based on the individual and collaborative research efforts, he published more than 45 papers in peer-reviewed journals with a high impact factor and in the national and international journals and proceedings. So we are very pleased to have Dr. Sanjeev Rao Garu here today to discuss research in sciences, opportunities, and essentials of project proposal. He is here to share his energetic and refreshing perspective of his experience. Please welcome Dr. Sanjeev Rao Garu. Thank you, sir. Thank you. Please proceed.
Okay. Good morning to all, and I'm very grateful to Professor Sunita for inviting me and giving a brief introduction about me. What I understood is the group is from budding science students to the mid-level scientists working at various places. So when I was asked to make a presentation, I thought of combining 3 or 4 aspects into a 1.5 hour talk to motivate particularly the young students and to guide the mid-level scientists working at different places, either teachers or scientists. Professor Sunita, can you give me the presentation? Okay, so today I chosen the topic research in atmospheric sciences, opportunities and essentials of project proposals. It contains 4 keywords: the research in the subject of atmospheric science, and where are the opportunities, and how to write a project proposal. Many times people could not understand what is a research and where are the atmospheric science avenues to do the intensive research, and where are the opportunities available within the country and outside the country. And simply writing a proposal will not fetch any advantage. So you have to follow certain principles and guidelines. So today we are going to touch upon these 4 keywords. What is research? Where is the thrust areas in atmospheric sciences, and where are the opportunities in India and abroad, and how to write a project proposal, and what are the key elements. Next. So the first question is, we have to ask ourselves, what is research? People say it is researching. So it is a creation of the new knowledge and analyzing what is existing, how we can do service to the society by identifying the new tools, new processes, new understanding, and how you can intervene into the betterment of the society by doing a research, by creating a new knowledge and use of the existing methods and technologies, data, or whatever it is. And this could be a part of the synthesis of the existing knowledge, identifying the gaps and create new outcomes. So what is the requirement? So this is called synthesis and analysis of the previous research. Unless you know your past, what is happened, and where are we are, what are the sources of the data, and what are the tools available, what are the techniques available to us. So we cannot create a new knowledge and new outcomes. So this is basically the research is defined in this part. So it is a curiosity driven. So it is not the forcible. You have to create a new knowledge. How you can create a new knowledge unless you have the intention to do, unless you have the motivation to do that. So next, please. So there are different types of research. One is the basic research or the fundamental research, to look into what are the fundamental issues in physics, chemistry, mathematics, like meteorology. And the problem-oriented research, suppose you are talking about the climate change, is a problem-oriented research. Anything doing the climate change is a problem-oriented research. So there is an applied research. Applied research is whatever research you are doing, it is applicable to a particular society or particular stakeholder. Suppose weather research, it is applicable, forecasting is applicable to all sectors of the society. Whether it is industry, or it is a common man, or it is any type of activity in the society. Then the problem solving research. Suppose there is a heavy downpour in the particular region, why it is happening and what causes it is there. So whether is there any specific to that location or it is a regional effect or the global effect, how it is happening. To solve such problems, it is called the problem solving research. So there is a quantitative research. Quantitative research is in terms of looking into the past data, looking into the trends, probabilities, like that. So suppose climate change definition. So it is going over a long period, how the trends are happening in different components, temperature, CO2 emissions and other things. So that is the type of research we are anticipating under the quantitative research. The qualitative research is the past history of the climate. What is happened in say 1 lakh years back in the geological time scale, how the events are happened, wet, dry, or something, how it is happening during the epics like Mahabharata or the Ramayana. So these all are the descriptive and qualitative research. And in addition to this, there are other types of research also. For example, survival research. That means the institution or the university asks the people to do some research. So for that purpose, without motivation and without intention, because of by force, you do some research which is called the survival research. Anything out of this comes under the survival research. There is no focus. It is doing for the research. It is a survival research. So out of this, if you look into whether you can do a fundamental research, that means you are looking into solving some hypothesis, some theories, you are questioning the existing processes, and you are trying to advance the knowledge. So then applied research is whatever is required for the society, you are addressing those issues. And under this problem-oriented or applied research or the basic and fundamental research, we can progress further. Next, please. Now look into what is the quality of the research. So whenever you are doing research, look for the novelty and originality. Photocopying and taking from others and repeating the work in your region is not acceptable as a good quality research. It is a survival research. So whatever is doing, you have to critically assess the existing knowledge base. So whether it is in the local, regional, or the international, whatever is knowledge available gathered by the other scientists, you have to assimilate and come to a conclusion that what is available today and where are the gaps, how to proceed further. Then there is a technical soundness, what methods you are using and how you are interpreting your results. The methods using, maybe some people say a regression equation is good enough to say it is a model, but now with the computational facilities and the advancement in technologies, simple methods will not do. You have to say the latest technologies or the solutions we have to adopt. Then interpretation of the results. This is one key element we look into the good quality. Whatever the data synthesis you have made, and finally you prepare a one graph or one table. How to interpret it? And it is the uniqueness of yourself. So others cannot do that. So how best you can do the interpretation and get the conclusions and draw some hypotheses. So this is the more important to say it is a good quality research. And how it is useful to the mankind. Finally, we look into the where is the application. It is the advancement of the science or it is usefulness to the society or the different mankinds. And it is the domain knowledge and way forward. Suppose if something is known and you have added an incremental knowledge and you are posing more questions so that there is a way forward, how you can look forward so that your research is being quoted by the people, cited by the people so that you are recognized as a particular scientist in a particular domain. So that is a more important thing to say it is a good quality research. Whatever one or two publications we have in a good quality publications, this has to be referred by the various people. So and so has done this work, and I am continuing this. Or sometimes the critic may be also a good. Suppose X has done this, and but this is not good, and this is the lacuna in this, and identifying the disadvantages or defects in the methodology or the interpretation is also a good. That is a critical thinking and way forward. The implications and outcomes, whatever research you are doing, it should have some outcomes. So there may be scholars or the research students getting tried, or some good publications are coming, or some new tools are being developed so that it can be repeated and upscaled for the larger utility. So next, please. Then innovation. So without innovation, the research cannot progress. So there should be new ideas, new thoughts, creating new thoughts, new imagination in the form of either technique or a method or a device, whatever it is. So you focus on the one thing, whether you are good in the technological development, you are going to define a new technology or upgrade, and you proposing a new technique or a new solution, new method, or you are looking for a new device. So suppose automatic weather station, there are different components. Can we develop a one component? Suppose a pressure sensor is there, which is totally expensive. Can we develop a cheaper device to measure a particular thing in a smaller size and a good retention capacity, and it is longevity, more longevity. Like that, you have to think the uniqueness. Then better solutions. So application of better solutions that meet the new requirements. So the society, every day in and out, we are getting the new requirements. Suppose weather forecast. Once it is a regional forecast is good, but now it has become a too local. Suppose a function is happening in my house, so I am looking for what is forecast during that period and that particular time window. So that is the requirement we are looking into, so that there is a highly precise weather forecast we are anticipated by the people. So how to meet this societal need. And this innovation convertible to the products, processes, and services. So particularly, whenever you are doing the research, the innovation component leads to either a patent or a prototype development or a improvement in the services. So for example, we are giving a local weather forecast at the Regional Meteorological Center. How best we can improve, whether your research is contributing to the improvement of the services is an important act. Next, please. So to do the research, we need a proposal. What is that proposal? It is in a document prepared by the researchers by providing the details of the context and the description of the proposed work or the proposed the program, how you can do, how much time it is required, what are the financial implications are there, why you are motivated, what is the scope of research, significance, and what methodologies you are going to use, and what is the expected results and societal application. This is a nutshell as a research proposal. Now we are starting from the research definition to the importance, quality, and the research proposal requirement. But now, why it is required? Next slide, please. So, why to formulate your research project proposals? So, it is essential for the faculty, whether assistant professor or associate professor or any scientist, in service. And also the students is important to prepare a proposal because they have to go for a dissertation. MSc second year, they have to submit a dissertation. So this also reflects a part of this, why you have to write a proposal. So for the faculty, it is a freedom to carry out innovative and stimulating ideas and thoughts. So it is, you have some thought, so you have to implement that. But your institution or university is not able to provide the support. But you can write a proposal and get the funds from the either state government, central government, or the private institutions, and you can implement that project. So in this way, you are very active in your domain knowledge. Otherwise, you are simply going to the class and coming, and it will not help in your career. So with this, you can have access to the additional equipment. You can procure yourself, or you can have collaboration with other people where the expensive equipment is available. And you have the travel and field work and staff at your disposal, and whatever you want, you can do it. Whether it is a experimental work, basically to repeat the thing, and you need manpower. So everything is available. At the same time, you can also support scholarships and some internships to the students. Once you have a project, your employability will improve. So because your biodata will enrich, I have received the grants and to do the research, so your employability potential will increase. Suppose implemented the project and you have a good publications 2 or 3 from the project, and it is very highly cited, and you will be recognized for the rewards and awards. So unless you are recognized, you don't get any reward. Reward in the sense as a scientist recognition, or the award like Bhatnagari Award or Swarna Jayanti Fellowship or any UNDP or WMO Fellowship, something like that. So you don't get the awards and rewards. At the same time, you are recognized as a scientist. You have the access to the national and international R&D facilities. So this is another important thing. So you are being connected with the outside the world. So next, please. Yeah, let us see some 2-3 cartoons. What is the Earth system science? Once you know the research is an important component and where to do, we are the scientists, basically meteorology and oceanography. But that is the very old nomenclature, meteorology as a discipline and this oceanography as a thing. Now, if you look into the global system, Earth system, it is a spheres. So looking into the atmosphere as a sphere, geosphere, hydrosphere, and biosphere, and together. So without soil and without earth, there is no agriculture. That means there is no biosphere, and there is without atmosphere, there is no crop productivity or the food production or the plant production or the another way. Without atmosphere, you cannot do. So the systems are interactive. So whatever we are doing, we cannot do isolatedly. So we have to go for a multidisciplinary and interdisciplinary. Next, please. So why it is important, the atmosphere for the life on the planet? So the chemical composition, which is essential for the life, and once the life exists, there are other requirements, the hydrological cycle or the water cycle. So evaporation, transpiration, evapotranspiration, how it is going to the atmosphere and how it is returning back through clouds as a rainfall, and how it is penetrating into the soil, how it is getting back. So this entire cycle is an important aspect to retain the
Hello, sir, is it working? Hello.
You can display it now. Okay. Sorry for the interruption. My internet has disrupted. Yeah. So now coming to the natural disasters, the air pollution, and these all are happening in the lower atmosphere. So the spacecraft dynamics and navigation is another important aspect in the atmosphere. And all the telecommunications, what we are receiving today, is because of the space telecommunications, because of the atmosphere. Whether it goes to the aerosphere and return back the signal, so we are receiving it. Then the aircraft navigation, landing and takeoff is also an important aspect in meteorology. So these are the important components why atmospheric science is an important to the survival of mankind on the earth. Next, please. So if you look into this cartoon, you might have seen several times, but this is reflecting how the water and earth is distributed over the globe, and how the humans and the animals are living together and producing several anthropogenic issues. And there are industries which are giving the pollution, and which are the ecosystems which are producing some gases to the atmosphere. And the agriculture is itself is producing the methane and nitrous oxide emissions, and which causes the global warming. Why it is happening? It takes up to the atmosphere, to the lower troposphere, to the middle troposphere, and then before tropopause, it will have a transporting dispersal mechanism. It will take it to the other regions. The chemical transformation will take place. There is a lot of chemistry in addition to the physics, and then beyond the tropopause, and the troposphere, stratosphere exchange process will take place. The ozone depletion and ozone chemistry plays a major role there. So the overall, if you look into the as a system, so there is evaporation, transpiration going through the clouds and going to the upper, and there is a dispersal from one region to other region, and there is a transformation between the atmospheric layers. So all are important for the livelihood. These things, how you can convert, how these processes are converted into the real-time the theoretical aspects on the education systems. Go next slide, please. Yeah. So here, if you say there is a one hand, there is a human activities, including agriculture, including the ecosystem services, or including the industries, and everything comes as a human activities. The land use, land changes, and the industrial activities within the land, which is, we call it as a terrestrial ecosystem processes, and it leads to the energy and moisture exchange processes. And then we look into the marine side, oceanic side. So there is a biogeochemistry and the ocean dynamics play. And altogether, the atmospheric physics and dynamics is related to the incoming energy from the radiation and volcanics. So a lot of dust is emitted to the atmosphere. So the top of the atmosphere is contaminated. Your radiation levels will come down. So the external forcings are reduced, or it is more or less it is remain constant. And this leads to the entire system is reflected into the climate and the climate change over a longer period of time. So whether you are a physicist, chemist, mathematician, or whatever, either engineer or an agricultural scientist, so you have to play a major role in defining the weather and climate processes. Next, please. Yeah. Now coming to what is the atmospheric science? So I am always putting the questions. Please remember, because once we are doing a research or making a presentation, you have to question yourself what you are going to look into. So this is what is atmospheric science. We are talking about the processes at the regional level and global level and a local level. So the atmospheric science is an umbrella term which includes the all components of the atmosphere, processes, and the effects of other systems on the atmosphere. The direct and indirect effects of all the components is being considered as an atmospheric science. Includes meteorology. Meteorology includes atmospheric chemistry, atmospheric physics, and all this focusing to the weather forecasting. So we know only the weather forecasting. To give you a better forecasting, we should understand the atmospheric processes better. So there the fundamental research and the basic research and the applied research play a major role to give you a better weather forecasting systems. Then the climatology, weather is an instantaneous value, whereas climate is over a longer period. So their climatology looks into both long-term and short-term changes, which defines the average climate and their change over time. We say climate and climate change, climate variability, all comes under this anthropogeny. And aeronomy. When I was a student, we used to go to the physics department to learn aeronomy. Mathematics department to look into the mathematics and statistics. So I don't know, at present the meteorology and oceanography is internally doing or going to the other departments. But it is an important aeronomy, the upper layers of the atmosphere, where dissociation and ionization are very important. Apart from this, now there is a new branches coming, planetary atmospheres, because our space program is looking into the atmosphere over the other planets like Mars and other solar systems. So this is an upcoming science. This is also part of the atmospheres. Basically, what is the boundary layer? What is the existing processes? Whether over the other planets is the planetary science system we are looking. To do all this, apart from the local observations, there are rocket sounds, radio sondes, radars, and the lasers, and many other equipment we use it to the monitoring and understand the atmosphere. So this is a nutshell what is an atmospheric science. So any branch dealing with the atmosphere as an envelope comes under atmospheric science. You say I am an atmospheric scientist means I know only the meteorology. No, you are supposed to learn all the aspects. Next, please. Yeah, there are 9 priority areas we can identify within the atmospheric science. The land atmospheric interactions, agrometeorology, which is food production, is very important, and the climate change and social impacts. So recent years, the climate change has become a very big player. The air quality and its impact on society, the air quality, indoor air quality and outdoor air quality is also impacting our society. And now the middle atmosphere observations and modeling has become a space weather is an important aspect because henceforth our communication systems are depend upon how best weather forecasts, space weather forecasts are being given. Even now, people are aware that how the weather forecasts are used in spacecraft landing, takeoff, and our INSAT satellites or any other outgoing equipment. And navigation and telecommunications, every person is having a telephone. The telecommunication has become very sensitive. Even a few seconds interruption is become a big problem now. We are accustomed to that. Then the cryosphere climate interactions, how the South Pole, North Pole is having the impact on the um, the Indian monsoon, also the snowpack, snowfall, and the glaciers over the Himalayas, or how it is impacting the Indian monsoon has become an important aspect. Even though snowfall and other things are considered as one of the parameters for long range forecasting, but we don't know what is the glacier climate interactions with another thing. Okay, so the planetary atmosphere already we have talked. So next, please. The challenges in atmospheric sciences. I don't want to go in depth because many of my colleagues are presenting specific topic oriented presentations. So this is short range to extended range forecasting. So hours to the days to weeks to months. That means very short range forecasting to the seasonal forecasting. The accuracies are more important. How to improve these predictions is an important challenge. And data assimilation, we have a variety of the data from the ground level to aircrafts, ships, satellites, radio sondes, radar systems. So how to integrate this is most of the data is assimilated, but how best we can use 100% of there and is an important thing. Because these all are not regular. It is an irregular. Some are regular. Most of them are irregular, but it is informative. And the scale interaction processes. So this is another area, fundamental research it comes, how the clouds are interacting, how the convection is leading to the various types of clouds, and how they are producing the rain-bearing activity, why some places we are having intense rainfall and why some regions we don't have any rain together, and these all are scale interactions. So how to look into that? How the turbulence plays a major role is another activity. And regional level hydrological cycle. So how it is. So that is an important area. Urban weather and climate. So heat islands and comfort zones is one area which we are very much interested because livelihoods are dependent on that. Next, please. Yeah, the scale interactions we talked about, but again, the heat, mass, and energy transfer is an activity with respect to the waves, whether it is the gravity waves or Kelvin waves or Rossby waves, how it is, and where our environment is looking at. And the troposphere stratosphere exchange processes, how the moisture is included into the stratosphere, how the ozone is penetrating into the lower troposphere, what is the chemistry we are experiencing over the tropics and extratropics, how the equatorial region is different from the tropical region. All this comes under troposphere stratosphere exchange processes. So the heavy rainfall or torrential rains is one area. The droughts, hailstorms, thunderstorms. In recent years, the thunderstorms and the electric discharges has become a major issue, at least in southern India. So how it is happening in recent years? What changes is happening? So this is an area of concern to us. The aerosol cloud interactions. So there is the clouds, microparticles, and how these microparticles are acting as a hydroscopic nuclei, and how it is clouds are being generated. So if you recall, in recent years, only metropolitans are getting heavy downpours and continuous downpours. For example, Hyderabad, every day we are getting heavy downpour. Why it is happening? Is it due to aerosols or the local environmental changes? What causes it? And as a meteorologist or an atmospheric scientist, can you explain? Can you predict? Can you give guidance to the local governments? Next, please. So then methane and nitrous oxide emissions from the agriculture is an important. So ozone, we understood that at least 15 to 18% crop losses is happening due to the ozone thing. So how this productivity is influencing the environment is another area. So chemical transport modeling. So this is another area. Once it is an important, there is active groups in the country, but now we see 3 or 4 groups are working in chemical transport modeling. Even though some people use the WRF model for the chemical transport, but I feel you have to use the regional model for the chemical transport. So we talked about cloud aerosol interactions, human health and animal health. One sector we neglected is animal health. We need milk, we need meat, but we don't look into their survival, how the atmosphere is impacting the population dynamics of the animals or the products like milk, meat, and other aspects. So this is another area, the human health. So now the COVID, it started at one place and spread into the various regions. Is whether is a carrier from one region to other region? How the local environment is influencing, because we are seeing the regional differences in the COVID pandemic. Is the weather has any role in that? So there is an interesting aspect here also. Next, please. Next, please. Yeah. The cropping systems and agronomic practices, agrometeorology. Dr. Ramakrishna has given a good talk on agrometeorology. You might have seen different cropping systems, how each and every agronomic practice followed by the farmers are dependent upon the weather conditions. How the pest and disease forecasts or the spray of the fungicides and pesticides are used indiscriminately to protect the crops. How the irrigation is being given unscientifically, using the more water, more salinization. So the harvesting is also not practiced in a scientific way. So there is another area, storage and marketing. So now one goods can be transported from one area to other area. How the atmosphere is influencing. Suppose a banana is harvested in Tamil Nadu, taken to the Delhi. It takes certain hours by air or by train. So during that period, what type of atmospheric conditions it is experiencing, how the quality of the produce is taken place. So like grain storage and marketing, everything is involved. So air pollution meteorology, the bioaerosols have become an important aspect. Again, we are talking about the COVID type of thing. So there are several bioaerosols at local level. From hospital waste itself is generating, how it is transporting to the other regions. Then one area, indoor and outdoor pollution. Indoor pollution is once as an important subject, but now again it has become reappearing as an important subject because culture has been changed. So the mass, what we are going into day in and day out, how much pollution, how much particles we are transporting to the inside the mall and how they are circulating within the malls because of the air conditioning is another threat. So biomass burning, so even though we thought of controlling and educating the farmers, still it has become an issue, particularly Delhi region. The space weather observations and how it is solar radiation impacting the regional climate, ozone depletion. So these all are some of the areas which you can choose. Whatever topic you have chosen, it is important to concentrate on that topic and related areas. You focus on that. Next, please. Yeah, soil, plant, atmosphere. So the microclimate, how it is influencing the soil dynamics. See, the soil is varying from village to village. Within village, you can see 3 or 4 types of the soils. How the dynamics is influencing the soil moisture retention capacities and how it is giving to the back to the plants and through plants, how it is giving to the atmosphere, how the cropping systems or the forest regions are influencing, how the chemistry part is involved and giving back to the environment and receiving back as a rainfall is an important study. It's a soil plant atmospheric interactions, because whenever you are changing the varieties, so we are changing the plant material. We have to study the gene environmental interactions and how it is influencing the productivity. As we also talked about the animal atmosphere interactions, how the temperature, humidity, and radiation is influencing the animal growth. Lactation period, suppose one region to other region, the lactation of the animal is different, and how the milk productivity and meat production are influencing by the local microenvironment is important. The ocean atmosphere, because we are surrounded by the oceans, North Indian Ocean, Bay of Bengal, and Arabian Sea, how the sea surface temperature, coastal processes, and air sea exchange processes, and particularly the hemoalliance circulation or the coastal circulations are influencing our local environments as well as the regional climate. And the cryosphere, so here I can say the extent of the snow cover and ice packs, and particularly the aspect and which direction the glacier is there and how the snowpack is affecting the radiation, and how the wind patterns are influencing, and this how the slopes are, how the depth of the snowpack or the glaciers are important to the monsoon. So this area is a very virgin. Only a few years back we have initiated, and there are stations established within the Himalayas and Antarctica and Arctic. So this is another area of coming area. Next, please. Okay, so all are the modelers. So simulation of future climates and how it is varying, and how the water resources are impacting energy sector and food production and ecosystem level, how the scenarios, say 4.5, 8.5, there are scenarios, and there are many studies are happening, and it will continue because there are many assumptions in this study. So if you can take up, you look into what are the assumptions they made, how realistic they are, whether we can correct to our local environment and do that. The space weather research, and finally the geosphere, biosphere, and cryosphere interaction. So the spatial and temporal variability of the rainfall, which is a very important component, because there is no year where the monsoon failed over the Indian region. But there are many years the interannual variability is significantly influencing the Indian economy. At the same time, within the monsoon season, there is no similar rainfall pattern in any of the 4 months. Not only that, there is no two consecutive years the monsoon distribution is similar. So there is a lot of complexity involved in this. So how to look into this? How these variations will impact the ecosystem services and society at large. Next, please. Once we know there are various issues, so we ourselves cannot do. We need a collaboration, whether at the national level or international level. Why there is a need for the collaboration? We need the interactions between young and mid-career scientists and technologists to look into what to develop a new science. And this depends upon the mutual trust and partnership. Maybe leadership evolve over a period of time, and this leads to the entrepreneurship also. Suppose now the weather satellites and weather channels are getting increased in our Indian context, and there are many apps are developing, so the entrepreneurship is coming up. So, sorry. So there is a requirement to encourage private partnership and foster elements of innovation and social applications, and creating culture of cooperation between academia and academics and industry. So this is the requirement. So far, the academics is not interacting with the industry. Now the industry is coming forward to the academics to make a collaboration, to invest on the academics, to the advantage of the industry. Next, please. Now, where are the opportunities? Because most of you people comes from the universities, and University Grants Commission gives a particular grants, which is called the minor and major grants. And it can go up to 67 years, and either whatever the college or any discipline they provide. So there is a social science and the basic sciences. There are two different things. And research projects in sciences, engineering, technology, medical, pharmacy, and it comes to 20 lakhs, and the remaining humanities, social science, which we are not concerned, it is about 15 lakhs. So here, this is the first window to the college teachers and the faculty. Next, please. Here, the recently come up with the UGC faculty research promotion scheme. Here, I would like to emphasize here how the research is important, how the publications are important, how the research projects are important. If you look into the first startup grant, which will be provided 10 lakhs to an assistant professor joining in 1 year, within 1 year. See, you see the requirement? You should have a PhD with 5 research publications in Scopus or SCI or Web of Science, listed journals. So the conference proceedings, so textbook volumes or the paid journals will not work. Now we have to go for a good quality publications, 5 research publications. During the PhD itself, you have to go for a 5 research publications. So research scholars who are working in the department for leading to PhD in whatever the department, please note, you have to come up with 5 publications which are listed in SCI or Web of Science and the Scopus databases. This is important to get the initial grant from the University Grants Commission. For the mid-level, there is a stringent requirements. Please look into this. You have to have your publications, cumulative impact factor is greater than or equal to 30. Whatever publication you have, the impact factor cumulative. So it should be greater than 30. And you should have your 5 sponsored research projects. 5 sponsored research projects, whether it is an internal or external. And you should have a 10 PhDs full time during the last 3 years, or 3 during the last 5 years. So the requirements are mounting to the faculty. And if you are a senior scientist, it is a BSR faculty fellow, 50,000 rupees per month for 3 years, in addition to the 5 lakh grant they will provide. You see, you should have 3 sponsored research projects as PI, and there may be other. But the cumulative impact factor should be greater than 50. That means you should have a good quality publications from yourself and your students. There should be 15 PhDs in basic science and 10 PhDs in engineering or science. So you make a assessment, the requirement for the UGC in future or from this year onwards, and you should have a quality research publication. And quality research publications and the sponsored research projects. So now go to the next. Similarly, the Indian Council of Social Science Research also supports theoretical, conceptual, and methodological or policy-related projects. This is also varies from 5 lakh to 15 lakhs as a major project, and up to 5 lakhs is the minor project. But the time duration 1 year to 2 years. Now, here there is an important aspect in this is this social science research also supports high quality independent program of research. Also to provide opportunities for training of future researchers. So there are two components here, the human resource development and also to look into the quality of the independent program. So there are two things, and the third one is promote collaborative multidisciplinary research activities among researchers in the social sciences. So the meteorology, climatology, and the geography are considered by the social science research as a social subject. So you can look into whether it is whatever the thing, theoretical, conceptual, or methodological studies you are planning, and it should have a collaboration, it should have a quality, it should have a manpower requirement. Next, please. Yeah. Once if you look into the UGC, AICTE, or the ICSSR type of institutions from the academic side, the Department of Science and Technology provides the major funding, and irrespective of the institutions or the colleges or the universities. Because here we look into the candidates, the quality and qualifications, and quality of the proposal and the qualifications. So that is how your biodata looks into. There are four components. We'll look into the first scientific research. The inspired faculty. How many are inspired faculty here? I hope few people may be the inspired faculty. Once we have completed the PhD, and the inspired faculty gives around 85,000 rupees for 3 years, with around 15 lakhs research grant per year. So you have to write a good proposal. That good proposal is evaluated in terms of various aspects. I'll come to the next. What is that? So there are other things. At the college level or university level, if you want to go for a fixed grant, there also you have to write a project proposal. And the SCRB is a separate entity. I'll come there. So next. And if you want to go for any of the research projects, whether it is a technology development and transfer, the amount will be better. So maybe a few crores, 2 crores to 10 crores type of thing. Or the climate change, another area where you can get a huge number of grants. So there is a mission mode project on climate change, so which also includes the Himalayan glaciology, climate change mitigation, science, and adaptation aspects, and whatever the domain knowledge you have. And NRDMS is another area where you can go for the local area developmental activities, including GIS and other local features, assisting the local governance. Also, some sort of landslides, how it is, disasters are happening. So there also will get support from the NRDMS. And the international S&D collaboration, bilateral and multilateral collaboration, we have several countries, and there are country-specific proposals and the group-specific proposals like BIMSTEC, SAARC countries, or the European Union countries. So there are several avenues are open. We'll come to I'll touch some of these things. And then there is a C division, Science for Equity, Empowerment, Development, and various proposals are given here also. How your research is implementing to the societal level applications. Then there is a state councils and other things. So in a sense, the science and technology is one agency. They have various schemes to support the weather, climate, and atmospheric science. Not as an individual domain, you have to look into your multidisciplinarity. So next, please. The Department of Science, the Department of Space, they have the RESPOND program, research and academic the three components they will provide: space science, space technology, and space application. So here, I suggest you go to their website and see thrust area document. There are more than 300 pages document is available, and each and every component, and there are the sub areas identified. How that sub areas are useful to the space weather is clearly given. And this is one area up to 15 lakh rupees. You will get a project proposal on three aspects: space applications, space technology, and the space science. And various aspects, whatever we have dealt so far, and all the areas are incorporated in one way or other as part of the remote sensing and the GIS. Next, please. Yeah, Ministry of Earth Science. So it is the flagship again, Ministry of Earth Sciences. They have the 6 domain-specific program advisory committees, but every time they look into the again interdisciplinarity. The atmospheric science component covers all weather science, the agriculture, or other aspects, environment, aerosols, and everything. But 60% should be the atmospheric science, and 40% is the other domain. So this is the combination they look into, either geoscience or the earthquake will not come at some time. And there are various schemes, because I am not going into the minor details. So this is one area, NPDF. But here you have to write a project proposal and your biodata and the project proposal weights equal weightage. That means what type of publications you have received from your PhD program and how you have implemented your PhD program, and whether the present proposal is the extension of your PhD program or a new area you have chosen. Lakh rupees. Here you can get up to 30 lakh rupees for 2 years. 30 lakh rupees for 2 years. Mostly people use for the establishing their own labs, because you are a fresh appointee in any of the recognized institutions. So within 1 year, you can apply for SRG. So here also you look into your and how your citations has gone for the last 3-4 years, how it is impacted the society. That means, is there any significant outcome from your PhD program and the postdoctoral program? And it is attractive, 30 lakh rupees for years. To my knowledge, most of the people go for so 25 to 26 lakh rupees, they will go for the equipment. The remaining is sundry, like consumables, contingencies, and other things. There no fellowship is given for the SR, because you are young and dynamic, and you yourself can do that. So the next is the core research grant. Earlier we call it as external research, but it is a core research grant. And if your idea is good, implementation process is innovative, and some new dimension of the results are expected, either incremental benefit to the knowledge, or a process is expected, or a prototype is expected from your research. So the grant is not a limitation. So normally they go for up to 80 lakhs projects, but you can go beyond 80 lakhs. And there are other schemes. If you are established a scientist, you can go for other scientists, other programs like IFA, in terms of research in high priority areas. It is up to 15 crores, something like that. So there is a STAR program. If you have 3 projects continuously implemented in the government funding, and their rate is very good to excellent, and then you can compete for the STAR program. And this is about 80 lakh rupees they will give for 3 years. So like that, there is an imprint. I'll come back to the imprint. There is another area. So suppose the EMEQ called Empowerment and Equity of Opportunities. If you belongs to either SC or ST, a community to uplift your thing, and there is a scheme called EMEQ, that is Empowerment and Equity of Opportunities. Up to 50 lakh rupees for 3 years, they will provide grants. There is no co-PI, only PI. And again, your publications and your experience and your outcome is looked into in addition to the quality of the project proposal. Okay, so then there are overseas doctoral and postdoctoral fellowships. The $2,000 per month for giving to the doctoral fellowship, overseas doctoral fellowship. And postdoctoral fellowship about $3,000 for a 1 year postdoctoral and up to 5 years for the doctoral fellowship. But here, the requirement is you have to get admission into the top institutions in the US or any other country. Top institution, you have to follow their admission process and you get admission. And SCRP is having a MOU with different universities where you can avail fellowship. Every year they will give around 50 doctoral fellowships and 50 postdoctoral fellowships. And you have excelled in the research and you have high citations, and there are many research students who have come up, and then you are all recognized for some awards like Bhatnagar Award or the Samaji Fellowship or any other well-recognized awards and fellowship in the academies, Indian Academy of Science, Indian National Science Academy, Engineering Academy, like that. There are academies in India, national level. If you become a fellow of the thing, then you can have a JC post fellow. This is for 5 years. And 15 lakh rupees, they will provide grant every year. They don't ask the minor details, but in addition to that, you can use whatever way you like. This is the recognition. It is the basically recognition. There are other fellowships which you may not be interested, but you look into the international travels. Most of the young people want to visit other countries and present your results in international conferences outside India. So there is an opportunity every year around 1,800 to 2,000 travel grants being supported earlier, and it is continued, international travel support scheme. And the Air India travel and scientists, you will get full travel reimbursement and registration fees reimbursement. Whereas the senior scientists, only the travel grants, Air India return travel will be provided. Then recently there is another scheme has come, Accelerate Vigyan, and it is for the training. Earlier we used to provide training programs as a part of the program advisory committee system. Now there is a separate program called Accelerate Vigyan for the intensive training. So it is up to 3 weeks training, and they are expecting at least 1,000 training programs in the next 5 years. So there is a good opportunity to involve in the training programs and get enriched yourself. Next, please. This is an imprint program, so impacting research, innovation, and technology imprint. Even though it is looks for engineering by the MHRD, there are 3 components where we can contribute: the environment and climate. So how the industry can look into the environmental mitigation and the climate. So how the equipment can be generated with lower rates, pollution and other things, so that climate mitigation can be taken place. And there is a water resources and sustainable habitat is also related to the atmospheric sciences. So here also is a good opportunity, but you have to have a collaboration. Without collaboration, you cannot succeed here. That is one of the requirements. So industry, the academics maybe 3-4 institutions come together, but at least one industry partner should be there. How to take further your deliverables. That is whether it is a prototype or a upscaling of the equipment or whatever the technology we are being generated. Next, please. Yeah, there is a now coming from the national to go for the international collaboration. There is a Indo-US assertive form. So before going into the collaboration in a major way, we have to look for the bilateral workshops, symposium, and conferences. So we can host or we can participate in this, and then you can have a networking with the scientists for a collaboration and go on interacting with them and develop a mutually collaborative project, so that the US side will be supported by the US government, Indian side will be supported by the SNT form, Indo-US Science and Technology form. Also, they create a virtual network center. Suppose atmospheric science is a requirement, or the extremes, weather extreme prediction is an important aspect, so that we can have a virtual network centers, so that what scientists working in India will always be interacting with the other side, and there is a mutual visits from both the sides. So this is called the virtual network centers, and it is virtual. There is a center of scientists from the both sides, but it is a virtual. And frontiers of science and engineering, there is another call looking into by November 2020. Recent call is there, so you also can look into that Indo-US frontiers. And if you look into the other things, endowment fund is available. So India Innovation Growth Program is available. So don't think your atmospheric science or the meteorology is not a contentable component here, but you have to project your ideas, how it is influencing the society, and how the US side thinking and how Indian side is thinking, how we can make a collaboration and develop a new technology. So this is the important here. And women scientists, there is a separate fund for this, and at the same time, there is another science, technology, engineering STEM grants also is available. Next, please. Yeah. So there are different fellowships that are available. So the students can explore. Again, when you sit for the selection of the candidates, we look into the statement of proposal and your biodata. Statement of proposal reflects how you want to utilize this fellowship. Maybe 3 months or 6 months or 1 year, whatever the duration they announce, how you are going to utilize. That is a statement of purpose. It should be very clear and convey the innovation and development. And your research. So what you have done in your master's, what type of dissertation you have, whether you converted that into a publication or not, and then what is the initial research you are doing in during the PhD and after the PhD. So there are different fellowships. So you can look into the even SN Bose Scholars Program is the master's levels and graduate level students who will take at least 50 students every year. And there is an Indo-US fellowship for women in STEM, for women specific science, technology, engineering, and mathematics. There is a separate fellowship grants are available. The women scientists can look into the technology part, science and technology, or mathematics. So then initiative for research and innovation in science, there is another grant is available. These all comes as a call for proposals. You have to look for the Indo-US Forum website and make a watch on that. When it is advertised, what is the last date for the application, and you have to prepare for that and you have to apply on time. All the international programs normally they don't extend the time. The time management is another activity. Next, please. Yeah, Indo-German collaboration. So you can have your bilateral research programs. Climate science is one area. You can have the joint scientific workshops, brainstormings, and strategic initiatives in another area. External programs. This is the broad area they make a collaboration. Next, please. Indo-German bilateral workshops. So here you can one of you people can make a bid for this cross-fertilization of ideas. So this is the keyword, cross-fertilization of ideas. You have some ideas, other side is having some idea, how to bring together, how to you can start initiating the research. And knowledge networks, there is another thing. And joint knowledge pools to address global challenges. So suppose climate change is a global challenge. So you can have joint pools, joint knowledge pools. And research partnership with mutual interest and respect. So this is another component in collaboration. It should be mutually respected and collaborated and mutually interested also. Next, please. Yeah, there are many things and how these projects are being evaluated at the international level. This is an aspect looking into the compliance of the thematic area, whether your proposal is looking to the thematic area, how it is novelty and innovation is component is there, what is the scientific scope, what are your credentials and competitiveness through publications, and the presence of knowledge experts. Suppose if you are a group of scientists who have put together has made a proposal, and what is your knowledge expertise in different lines. So the multidisciplinarity will come into the picture, and there comes to around 2.3 lakhs for 3 years. Sometimes there is a mutual 3 months mutual exchange programs are there. So this is the type of evaluation they will do. Finally, what my submission to you people are, your thinking process, your innovation in ideas and implementation techniques and drawing conclusions or interpretation of the results and publication in the good scientific journals is the only way to flourish as a scientist or an academician and a scientist. Next, please. There is another thing is Indo-Russian bilateral programs. There are 4 to 10 members, $1,000, $100,000 for 3 years is everything. So here you can see physics and space science, and chemistry and space science, biology, and the basic research in agricultural science. Also you can see the earth science. So under earth science is in the globally they look into the earth science is a part of the atmospheric science is a part of the earth science. So there are various ways and means to go for a bilateral program, and it should be a group. It's not the individual. Next, please. Having said that, what are the essentials of a new project? So it should address one of the emerging or trust areas and its social relevance. So we are talking about from the beginning, and it should be one of the trust areas, any of the trust areas. It should have a novelty and technical merit. And if you're having everything, it should be feasible to implement. And your expertise and credentials is also important by both PI and co-PI and collaborators. So these projects look for a human resource development. So opportunities for young scientists to nurture, and a group can be created within your laboratory or within your group or within your state or within your country. And potential collaboration. So and advancement in regional and national assignment system. So what is the incremental benefit we are getting out of this? So these are the essential components for a new project proposal. Next, please. Yeah, requirements. So you look into your scheme, which scheme you are going, and read the scheme properly, including FAQs, and assess your strength, whether your expertise fit into that particular scheme or not, and then identify the issue of contemporary. So they're given some trust areas and your ideas, contemporary in nature and implementable. So that issue you can take it and look for the literature and interact and discuss with the group working in your region. And then you can start writing a proposal. And as for the format given, each scheme is having a different format. So that is more important. So if you are not submitting in the same format, the proposal will be rejected at the initial study, and it should be submitted before deadline. If the deadline is extended, and most of the projects will be rejected because beyond time. Next, please. I think we are running out of time. Yeah, peer review process for the new proposals. And as earlier also we mentioned, good idea, innovative technology, proposal to university. So a reviewer, suppose a proposal comes to me for a review, I look into, is there any good idea or some innovative thought or a technology is proposed, a new method is proposed to investigate, or the problem is significant and today's contemporary world, or it is old and repeating the same thing, and the description of the research is very clear, and then looking into the reviewers you have to convince, because everything is a third party review. So the credibility of the proposal, achievability. So once given some X amount of grants, you can achieve the proposal. And practicality, yes, it is practical to develop and implement, and the results also is a practical utility. And repeatability and reproducibility. In science, we look into whatever the hypothesis or whatever the solutions we found, and it should be repeatable. And sometimes it is reproducible. If it is not done, and your research is not considered as the research. And the reviewers look into. I know some of the reviewers, whatever the technical program they are given, and they work with some numbers and look back whether this is feasible or not. And otherwise, they will return the proposal saying that it is not feasible to implement. So these are the review process. Look into the ingredients. Next, please. Now, this is the general format. So, because as I told, every scheme is having its own format, but we look for a general format, which is common to many schemes. And whatever the format is there, you have to fill the format. If nothing is there, you put not applicable or nil. Don't leave it black. Leave it black means incomplete application. So you have to fill each and every component. So these are the general format. Next, please. Yeah, the title of the proposal. Once a proposal is reached to the funding agency or the reviewer, he look into what is the title of the proposal. Whether it contains any information, whether it is informative or it is a general title, and it is too lengthy, or it is a two-star. Suppose smart agriculture. So the proposal, if you say it is smart agriculture, they say no, it is not a proposal, it is a scheme. And so your proposal should contain what is the innovation in this, what is the outcome expected, and what type of methodology you are going to utilize. It reflects in the title. It should not be too lengthy, too short. But it gives an impression to the reviewer, yes, this, the investigator is presenting something new. I should look into it. It is not a repetition. This is a new area or a new thought. It is reflecting in the title. Next, please. Okay. Next comes to the abstract, and sometimes is the summary of the thing, and it should not exceed 500 words. And very brief, because every project, when it is received by the reviewer, he reads the title and abstract. Once the title is says, okay, it is clear in thought and there is a content is expected from the title, and then looking into the abstract should contain only 3 components. 3 sentences or 3 into 2, 6 sentences, not more than that. You should describe the hypothesis or the scientific questions being examined to seek answers, or if you are looking for a design of a component, whatever it is, the idea, the innovative idea is available. Which we are looking into should be the first sentence or 2 sentences to explain. And this is the hypothesis or the question, scientific question. Then the overall goals of the investigation. That means once you identify the question and the issue and the methodology is known, you know what is the expected. So that expectations and the scientific investigation through this scientific. This is the 3 components, and one is the why you are doing this project and what are your goals in investigating this proposal or the experiments being organized, and what are the expected scientific and social benefits. There are the 3 components. If you have these 3 components is clear, and the remaining proposal goes through like that. So that means you have to, your issue has to be very clearly specified in the first 2 lines, 3 lines. And next, you say what is your overall goal and investigation, what new methodology you are looking at, or the new hypothesis you are going to examine, or how you are going to examine, why it is innovative, how it is novel, and why it is the uniqueness in this. And if you do these 2, and you get what are the benefits. So if 3 components are very clear, and the remaining thing will be automatically followed. Next, please. Yeah, introduction of the proposal. So it should not exceed 1 page. So what is the research problem? The question being investigated. That means in the abstract, first and second lines. So you have to take that a little bit expansion. I have given in abstract, so I did not write in the introduction. No, you have to explain the question. What is the research problem or question being explained, and why you are doing that? For that, you have to take the previous studies that have addressed this problem, and what are the disadvantages of it. So don't elaborate. As I told, it is a 1-page introduction. 1 page, within 1 page, you have to write the problem. What are the techniques or what are the scientific knowledge existing? What are the deficiencies in that? How these gaps can be filled with the new knowledge? How to generate that new knowledge? And finally, the scope, purpose of statement, which is called the SOP, purpose of the statement. So this research, the introduction starts with existing scientific issue and what is existing, what is not known, how to fill that gap, and finally what is. It is, in other words, the same abstract you are elaborating without compromising your space. So in this, the important references you can give in brackets. It's not necessarily X has done like this and Y is not done like this and Z has done like this, like that. You need not worry. You have to synthesize what you know about it and what you understood about the existing knowledge. And that is the real information you are providing to the reviewer. Yes, this is the synthesis of the knowledge I gained. So I know this. Okay. Next, please. Next comes to attributes, almost the statement of the problem, what I told again. It is a clarity and precision. It should be clearly stated. There is no ambiguity in making a statement. It should be precise. Next, please. Go on repeating. Yeah. Identification of what to investigate are an overreaching question. So, go back. Yeah. So here, in the methodology part, So you have to look into again, you have to write identify the questions, what is the question, and how it is important. And you simply define the key concepts. If you remember when I started my title, I told it is a 4 keywords. I'm going to talk on these 4 keywords. So like that, here you have to write what are the key concepts and terms, and what are the boundary conditions, whether you're looking into a small, narrow region, a field, or a village, or a state, or a region, or a globe. So that type of boundaries you have to convey. Then the importance and benefits and justification. Earlier in the abstract, we have given the importance and benefits as a keywords, as a one sentence. But now we have to elaborate and provide the justification. And don't write jargon of words. So nothing is required. You should be very clear what you are going to convey. And it is the entire thing is giving a snapshot of your understanding about such problem. Once you are clear about such program, and it will come automatically. Next, please. Yeah. So literature. So there is a 3 columns. Normally they put local, national, and international. Local in the sense yourself, your co-PI, and your collaborators. Maybe within the university also you can say it is a local. And the national means it is other universities, other institutions, other national laboratories, whatever the national knowledge base. And the international, whatever access to you. Now today Google is there to access, but don't copy paste from the Google. So you have to read the papers and write the synthesis of the thing, and mostly you synthesize. So if the same methodology is being used by the 4 or 5 people, you can say in bracket there is a people, and need not be too many references. So the latest and important references only you can provide. And the experimental or theoretical framework here you have to define to some extent. And here you have to find the holes and cite them, what are the deficiencies in the earlier works, and compare with the existing knowledge, the local to regional to the global level, how to make a contrast. So some are maybe similar, some are divergent results, and critically analyze and connect one to other. So that your literature survey very clearly says you have critically analyzed the existing knowledge, you have identified the issues, and critically cited the points 1, 2, 3, 4, and you're connected to one to other, and now you find what is the required. Okay, next please. The project objectives. So next comes an important thing is project objectives. And some people will write 10 to 15 objectives. No, it is the work elements. You may think it is an objective, but objectives are always the scientific issues and scientific questions. Suppose if you are taking a project, there may be a 2 or 3 issues involved in that. Those issues are the hypothesis, are the testing, validation, development, and like that, framework, design. So whatever it comes is an issue. Issue is an objective. So it should be quantifiable and testable. Suppose you have one objective, design of a experimental setup to study the heat waves in India. Okay, this is a subject you have. So what type of framework you are going, and once you finalize the framework, and if you completed that framework, then it is a one objective is completed. That framework can go into a journal publication. That means it should be in total from beginning definition to the existing different regions, how the definitions are varying from operational to the hypothetical to the theoretical ones, and how you are finding the difficulties and how you are bridging the gaps identified and like that. So whatever the topic you have, and whatever the narrow domain knowledge you have chosen for your research, it should be a clear, short, and not more than 3 objectives, and it should be quantifiable and to the identified issues. And here in the objectives, some people will include the methodology. The methodology component should not be significant in objective. Okay, if it is a new methodology being developed, yes, it is an objective. If you are using a methodology, already known methodology, it is not an objective. So if you distinguish these things, and your objective is perfect, it should be clear, concise, and informative and quantifiable. So please remember, a reviewer looks into the title, the abstract, directly come to the objectives. If these 3 are good, and then look into back to the what introduction you have given, whether it is proper, any typographical errors, any technical snacks, technical errors, and like that. Next, please. Yeah, methodology is how to execute. As already I mentioned something. So research, design, and purpose and selection of this methodology. What type of research design you are looking? What purpose? See, finally, the methodology should reflect the objectives, and objectives should reflect the title of your proposal, and it gives the particular results, expected results. So how you are going to select that? So if it is a data science related thing, what are the data being used, how you are accessing the data, how you are making the quality check, and how you are synthesizing that, what methods you are using, how they are the very new. So if it is an experimental study, what type of experiments you are designing, what type of simulations you are doing, and how you are collecting the output products, and what type of softwares you are using. And all this can be listed in 1, 2, 3, 4 like that, at least minimum 12. Every quarter, you can have a quantifiable work element. Every 3 months, you should have a quantifiable work element. So that even sometimes you miss that quarter, the next quarter you can pick up and complete. The project implementation is also an important aspect to get a new project, because time management is another aspect in this. So that is why normally the projects are either 2 years or 3 years, and exceptional cases it is 5 years. So for taking 3 years, you make a 12 quantifiable work elements, so that every quarter you can quantify. Maybe there is a 1 month overlap here and there, doesn't matter. So you have to make this as a chart. Next, please. Yeah, once here, you be ready. What are the limitations of your project? So already you have made boundaries, but the exceptions you have to mention here, the qualification and reservations. So suppose you are expecting to do some fast computing and you don't have the computational access, then there is a limitation. Assuming that I will get a certain speed computational facility accessibility, then only I can do this. So there is an exception and some reservation of that. Like that. So whatever it is. So whatever reservations we have. Suppose today COVID, we are not able to go to the lab and we are virtually working online. So if you are planning for a laboratory experiments, you cannot do that. So this is the type of expectations and exceptions we have to write, reservations. How to then you have to write about the what is under your control, what is not under your control, and there is limitations before and after. So suppose if the project has not granted, so you are not able to do that. Suppose if you granted, and how it will impact. Suppose if you are going for a collaboration, your collaborator is not cooperated, you may not be able to implement it. So there may be some under your control, some may be a natural problem imposed by nature. So this also you can keep it in mind at one side, because now itself you have to be very clear what are the limitations in your study. It may not be required in the presentation and the project proposal, but it is required. Next, please. Yeah, deliverables. So what is the new S&T tool is expected? So the solutions and other things, because we are investing a lot of capital resources, human resources, and also the time. And sometimes the outcome of the project may not be having any social implications. So that also you can write it is a fundamental research, and my understanding and my knowledge base will increase, or the country's knowledge base will increase. So finally, you have to say, you have to convince in the last few lines, like British system, and the implementation of this project is very important and most essential. So if you can write these two words with confidence by your objectives, methodology, and the essential component, any other things, you have to write the implementation of this project is most essential. Next, please. Yeah, bibliography and references. Many people will don't mind writing hundreds of references, but you be very clear about what you have given in introduction, methodology, and the other places. Whatever referenced in the contents has to be reflected. No one reference extra. Only those things in the same format, any of the journal format, uniform format you have to write. And don't make self-citations. So some people has the habit write their own publications citing at different places. No. So already you are known by your CV, biodata. So if it is essential, your research, past research is contributing something extra, something to the knowledge base, then you can incorporate that. Otherwise, you avoid. Next comes to the CV. CV of the applicant. So it should be as brief as possible. So don't make very high credentials saying that I am the director, I am the dean, I am the head of the department, these things. Because you are competing as an individual researcher for a project grant, not as a head or not as a dean or not as a director of the institute. You are as an individual, you are competing for the research grant. So only essay publications you list out, all the conference publications, textbooks, this, that, so you can avoid. And finally, the top 5 publications they lost. Most of the times, top 5 publications are top 10 publications. You incorporate only highly cited publications, so that it reflects you are publishing good quality papers, publications in the reputed journals. So investing on you is not a problem. So it will help to the country. Next, please. Yeah, so now the proposal is ready. So if you all follow, and the proposal is ready, because you yourself has prepared the proposal, and my advice is you give it to your neighbor. There is no intellectual property rights here, so simply give it to your colleague, so who can understand your problem and your research. Let him or her go critically to review the contents for the clarity, connectivity, and completeness in all respects. So for you it may be the good, but the third party it may not be good. Third person it may not be good. So once you correct the typographical and technical errors, then go for a plagiarism test. Now plagiarism is become an issue, and some software you have to use and test for the plagiarism. And now the proposal is, once if you clear the plagiarism also, maybe 10%, 15% is acceptable, that now the project proposal is ready for submission before due date. If the due date is over and this proposal for this particular scheme is not useful, okay, you can wait for the another opportunity. So next, please. Yeah, so this may be my last slide, and let us summarize. There are many opportunities to undertake high quality research in atmospheric sciences, various branches. So there is a we can identify the main pillars from the past 1.5 hours, whatever we have talked. So it is the innovation in thought process. So you should be very sharp and you have to be creative thinker, and your thinking process should be innovative, something new, and your thinking should be ahead of the others. So that is the innovation we are looking into. It should be inter and multidisciplinary approach to the projects, and your entire career you can go for a collaboration with the others. Individually, you may be better, but if you collaborate, you are exceptional. So the interaction with the stakeholders, various sectors of the society, see where your research is being utilized. So unless you interact with those people, understand their problems, and whatever research you are doing cannot be useful to those people in the society. And maybe it may be an NGO, or it may be a app developer, or it may be a satellite person, or is a weather forecaster. Whoever it is an important thing. Then the collaboration, and the national and international collaboration for the new developments in SLT. So these are the main pillars. You have to have an innovation in thought process, and you should have a multidisciplinary approach, interaction with stakeholders, including your neighbors, and the national and international collaboration. So thank you very much, and any clarifications, I am very glad to.
Thank you, sir, for your excellent and informative talk. Any questions from the participants? Yes, sir. There are so many questions. Let me ask you. Importance of the life on Earth. Add agriculture also in the slide. Okay. This is a suggestion from the Ramakrishna sir.
Sure. So this we will look into the ecosystem level. Sure. Without food production, there is nothing.
There is a question from Mahendra sir. He just want to know the writing proposal to take research on hypothesis. How can I conclude? I include outcome which I am going to get without having a detailed study on that. If it include, is it valid?
Yeah, it's a good question. If you have a problem identified, issue identified, and once identifying the issue itself, you know what will be the possible solution. See, that is the thing. That should be the possible solution also, you know. Once there is an issue, and if you address that issue, what is the expected solution? The hypothesis. And actually, you go for a null hypothesis. Whether this is good or this is acceptable or not acceptable. Okay, after analyzing the data, you accept the hypothesis or reject the hypothesis. So this is the type of research. So you have your intuition whether it is going to be accepted or rejected. You know in the beginning itself. Unless otherwise it is significantly different.
Thank you, sir. Thank you very much. This type of guidance is very much required, especially for the young generation to implement the basic research in universities or affiliated colleges or in their institutes. It is a two-way interacting or a two-way beneficiary for personal growth as well as the professional growth. So we are extremely thankful to you, sir, for your valuable time and your encouragement, especially in this webinar. Thank you so much.
Wants to something.
On behalf of all the listeners here, I would like to congratulate Dr. Sanjeev Rao. It's an excellent talk and has given a whole gambit of opportunities to the young scientists, how they can really think what kind of problems are there, research problems which they can take up, and how they can really make a good proposal. I think it's a very great one. And I'm sure, I know that this is being shared to all through YouTube link. So people can download it and go through it again. But great, really, Sanjeev, I'm very happy you are still being active.
So thank you very much, sir.
Yeah.
So,
I think we will all come to you again and again for your support
good,
for
sir, it's my passion. If
projects.
somebody is getting benefited from me, I always with them.
Yes, sir.
Great.
Yes, sir. Yes, sir. Thank you so much, sir. Thank you so much.
Thank you very much.
Dear
So good luck to
participants,
all.
thank you. Thank you. Dear participants, afternoon at 3 o'clock we will meet. Okay, thank you. Professor
What is the topic?
Professor Rajendra Prasad will talk on the coastal resources in a changing climate from Department of Geophysics, Andhra University. Thank you, sir. Thank you so much.
Thank you.
Thanks.
Right.